Hi everyone! Qt 6.10 was released on October 7, 2025, and it promises to make Qt development smoother, especially when it comes to building modern UIs and handling data more efficiently. There's a new Flexbox layout, easier Lottie animation support, and big improvements in accessibility. But what really caught our eye is how much boilerplate code you can now skip, whether you are working with C++ containers, QML models, or UI bindings. So the question is, does Qt 6.10 truly bring a breakthrough, or is it just another version bump? In this video we'll break down what's new, what works well, and what you should watch out for, especially if you are planning to upgrade. Stick around, because later we'll also show you how these changes impact real developers, especially if you are working on embedded products or high-performance apps. Qt 6.10 brings useful changes both in terms of UI and data handling. For QML guys, there's a new Flexbox layout. It's inspired by web technologies and make UI positioning more intuitive, especially when working on responsive layouts. Basically, Qt wants designers and developers coming from the web world to feel more at home. Flexbox layout in Qt works a lot like CSS Flexbox, letting you build flexible, responsive UIs, but instead of running in a browser, it's designed for Qt apps. You also get a ready-to-use search field, no need to build it from scratch, just drop it in and it works. Styling, icons, behavior, it's all there. In earlier versions of Qt, building something like this meant wiring together multiple components manually. You needed a text field, search, and clear icons, pop-up logic for results, plus styling and a lot of other tweaks. And keeping it consistent across platforms, that was on you too. Now with Qt 6.10, all of that is bundled in a single polished component. It's faster to implement, easier to maintain, and better for cross-platform consistency. Now, for those working with data in QML, things got easier too. You can now use TreeModel and SortFilterProxyModel directly in QML. That means less jumping between C++ and QML and fewer chances for messy integration issues. So, QML devs receive a lot of new features to play. Backend developers get their share of improvements as well. A new class called QRangeModel lets you connect C++ containers like std vector directly to Qt views. You no longer have to write a full QAbstractItem model just to show a simple list. Qt developers also benefit now from better platform support. Qt 6.10 works now with Android 15 and 16, macOS 26, and it includes a native Pipewire audio backend for Linux. And if you're a designer or work closely with one, there is improved support for Lottie animations. The new integration is faster, smoother, and can now be converted directly into QML code, which is nice. We'll cover each of these updates in detail throughout this video. Let's talk about one of the most common pain points in Qt development, which is connecting your C++ data to your QML UI. It's not a rocket science, we showed how to do that several times on this channel, but you have to do it right. Previously, sorting or filtering in a model in QML was possible, but it was slow and clunky because you had to drop into C++ implementation of QSortFilterProxyModel. And then you had to wire it back into QML manually. You had to drop back to C++, subclass QSortFilterProxyModel, implement filtering logic, expose the model back to QML, and suddenly your clean code turned into a maze of boilerplate spaghetti. Qt 6.10 fixes that. It introduces SortFilterProxyModel directly in QML. Now you can sort, filter, and remap data directly in your declarative code with just a few lines of code. No longer detour to C++, no extra classes, anything like that. Same goes for hierarchical data. If you wanted to show nested settings or tree of directories in tree view, you had to write a full-blown C++ model. That's a lot of effort, especially if the data was mostly static. Now with TreeModel in QML, you can define tree structures using native QML syntax, just like you would define a list or a menu. It's easier to write, faster to iterate, and much more approachable for teams that want to keep things on the front end. These changes don't just save time, they lower the barrier to entry for new developers. They reduce context switching between QML and C++, and they of course help teams build prototypes and full applications even faster, which is of course a huge benefit of Qt QML, that you can do things really rapidly. Now, if your project uses micro animations, like a loading spinner or a small interaction effect, you are probably familiar with Lottie. In earlier Qt versions, Lottie animations were rendered using QPainted. It worked, but the performance could be inconsistent, especially on low-power devices. And because it was all software rendered, scalability and smoothness were limited. It all depended on CPU. Qt 6.10 finally changes that. Lottie now runs through the vector image class item, which is hardware accelerated, and that means smoother animations, better performance, and less CPU strain, even on embedded hardware. But here's the honest take. Lottie animations in Qt used to be limited. No hardware acceleration, poor performance, definitely not production ready. This kind of hardware accelerated Lottie support has been standard in other frameworks like Flutter for years. So while it's great that Qt finally caught up, this improvement is long overdue. But still, it's a big step forward. You can now convert JSON Lottie files directly into QML using the new Lottie to QML tool. This gives you full control over animation properties inside QML, the ability to pause, loop, or interact with other animations. And if you work with animated SVGs, there is more good news too. Qt 6.10 supports SVG animations with CSS keyframes. If you are not familiar with CSS keyframes, here is what you need to know. There is a way to define how an animation changes over time, like making an element fade in, slide, rotate, change color, and it's done using percentage-based steps. Take a look at this example. In Qt 6.10, the same kind of logic now can be applied to SVGs, letting you animate transforms, colors, opacity using familiar web-style CSS declarations. It brings fluid animations into the Qt rendering engine without needing heavy custom code or external libraries. You can also convert SVG files to QML items. If you ever tried to connect a std vector, std list, or any modern C++ container to a Qt view, you know the drill. You had to subclass QAbstractItemModel, manually implement methods like rowcount, dataset, data, role names. That's dozens of lines of boilerplate code just to show a basic list. Qt 6.10 introduces QRangeModel, and it changes everything. With this class, you can expose any standard C++ container as a model directly. No need to wrap your data manually. No need to re-implement every model method. Let's say you have a std list of QStrings or even std vector of some tuples. You can plug it into list view or table view, and Qt takes care of the rest. If your container keeps QObjects with properties, this model automatically generates roles for you. It even keeps the data in sync. If your UI updates a value, the container updates too. If the container changes, the UI reflects it too. And it doesn't stop at flat data. You can use QRangeModel with 2D containers like a list of lists and plug it straight into table view. This change massively reduces friction for C++ developers working with STL-based code bases. You write less glue code, keep your data model clean, and you stay focused on logic, not plumbing. Let's now talk about a common headache in QML. You bind a UI element to some data, then the user interacts with it, and then the binding breaks. Sound familiar? Here's what used to happen. You would bind a spin box to a model property, but as soon as the user changed the value manually, Qt would override the binding with the new value, effectively breaking the link, breaking the binding. To prevent this, you had to add custom signal handlers, manually synchronize values in both directions, and most importantly, hope nothing desynchronized along the way. Qt 6.10 finally solved this with a new module, which is in Qt Labs. It's called Synchronizer. With this new type, you can keep multiple properties in sync without breaking bindings. Have a look at this example. No extra logic, no side effects. Just a reliable two-way data flow, even across models, delegates, and nested components. This module is still in tech preview, which means the API might evolve, but it's already a huge win for anyone who's had to wrangle complex state management in QML. Qt Graphs is getting better. In 6.10, the module gains a few powerful features. A new field surface graph for 3D data visualization. You can now fill surfaces with textures or gradients to make them easier to interpret visually. There is also a new change for multiple axis support in 2D graphs. You can add more than one X or Y axis. It's perfect for comparing different data series with different scales. And you have Z-order control. This lets you push selected graphs to the foreground, making it easier to highlight specific trends or alerts. Together, these features make it possible to build more dynamic, readable, and polished dashboards with less work. Or at least that's on paper, because we still need to explore those features a little bit more. Qt wants to push aside both Qt charts and data visualization and make Qt graphs the future. So if you are starting a new project with Qt 6.10 or later, this is where you should be looking. We actually explored this shift in detail in a recent video where we compared Qt charts, data visualization, and custom plotting in opposition to Qt graphs. Check it out if you want to see real trade-offs. So who really benefits from Qt graphs? These new features matter most for monitoring tools with lots of sensor data, industrial UIs that need real-time graphing, dashboards in fields like medical, energy, logistics, and embedded devices where rendering efficiency matters. If that sounds like your case, Qt Graphs in 6.10 might be the upgrade you have been waiting for. If you are targeting newer hardware or you build cross-platform apps, Qt 6.10 brings important updates under the hood, even if they are not as flashy as UI features. Qt now officially supports Android 15 and 16, macOS 26 Tahoe, and WebView 2 on Windows. That means smoother support for native services, new APIs, and future-proofing your apps for system updates. There is also Qt Genie 1.0, a new tool for Android developers. It helps you generate C++ Qt APIs from Java classes, making integration with Android and native services much easier. By the way, we are about to publish a full performance comparison between Qt and other Android. Specifically, by Android, I mean Kotlin, Jetpack Compose. So what's better for UI development? It's a must-read if you are choosing between these two for embedded development. You will find the link to the PDF in the description. Boot to Qt now supports Yocto 5.2, Walnut Core, I think that's how you pronounce it. So if you are using embedded Linux, you are getting the latest toolchain support right out of the box. For Linux audio, Qt 6.10 adds a native pipe wire backend. This improves performance and reduces latency, especially useful in professional and low latency environments. There's also new support for audio tone compensation via FFmpeg, giving you finer control over playback tuning. Should you upgrade to Qt 6.10? It's not a revolution, but for many teams, it's a real productivity upgrade. And of course, these changes will be present and more often used in all of the next versions of Qt. So if you build complex UIs with animations, graphs and model views in QML, if you work with mixed C++ and QML data layers, if you care about accessibility and future platform support, this release can save you hours of boilerplate and make your app more modern and inclusive without re-architecturing everything. But it's not perfect. Some features like Flexbox layout and synchronizer are still in tech preview, so you should expect their APIs to evolve. And it's hard not to wonder why things like Lottie support or modern layouting took this long. Other frameworks offered similar tools years ago. That said, Qt 6.10 feels like a clear step forward in closing that gap. So if you are starting a new project, there is no reason not to go with Qt 6.10, and if you are upgrading from Qt 5, check your dependencies, especially if you are using deprecated modules. We have made an excellent video that covers exactly what to expect from migration. So if you are building embedded products or performance critical apps, some of the backend and multimedia updates might be exactly what you have been waiting for. Let's wrap it up. If you have made it this far, thank you. Tell us in the comments what feature are you most excited about, or maybe feel like some of these should have been here in Qt years ago. If you want to see how Qt Graph stacks up against older solutions like Qt charts, data visualization, and even full custom plotting, we have got a detailed video for that too. And if you want to dive deeper into Qt's performance versus Android, grab our full comparison report, link is in the description. Thanks for watching, and if you found this breakdown helpful, consider subscribing. At Somco Software, we help teams build better embedded products using Qt, and we share what we learn along the way. See you in the next one.